Let's explore the quirks of Logic's Bitcrusher plugin. For testing, we use a test oscillator input signal. At the moment, it is a sine wave set to 100 Hz at -12 dB. We use a sine wave because it can be seen as the building block of all sound, since any sound can be modeled by a combination of sines, for instance. Up here, we visualize the waveform and the spectrum after the test input is processed. Every waveform correlates to spectrum. A single bump in the best spectrum is to be expected for sine wave. In order to showcase the spectrum of a quite contrasting signal, we will change the sine wave input to square wave. It sounds quite distorted, as we can hear. We still have the same fundamental, but on top of that, there are those harmonics. These harmonics have a certain relation to the fundamental. This harmonic has 300 Hz, this one has 500 Hz. Therefore, these harmonics are called odd order harmonics. If the harmonics would have the values 200 Hz, 400 Hz, and so on, we would have called those even order harmonics. After the visual metering tools, I am applying heavy limiting because we will have a lot of dynamics in the volume and the input signal is way quieter than some of the distorted settings we will try. So with limiting, we can hear the changes at comfortable levels. The Bitcrusher consists of 3 modules. The drive module that works in tandem with the clip modes and the clip level. The bit resolution, that is the actual bit crushing, and the downsampling factor. With no drive, the bit resolution at maximum, no downsampling, the plugin does nothing to our sine input signal, so we just see a sine wave and a single bump in the spectrum. When we raise the drive, we can see it just raises the gain until we hit the clip threshold. Our input signal is at -12 dB, and we push the drive to 12. One step further and we get the clipping. The waveform in this oscilloscope is more accurate at displaying the waveform than the one in Bitcrusher. We can see how the waveform gets clipped. When driving completely into the clipper, we can see a square wave and the correlating odd harmonics. Compare it to a purely generated square wave and we see it's kinda the same. Now let's change the clip mode to here and see how they differ in these extreme scenarios. The fold and wrap clip modes have a lower fundamental compared to the clip mode, but more emphasis on higher harmonics. Here the clip level can be lowered if we want. So instead of the 12 dB required to reach the clipping point, we can offset it by up to -10 dB. Let's reset the drive with a new clip level here. Now going over 2 dB drive will result in clipping. What does it mean to lower the bit resolution? The sound information is stored with 24 bits. When we use less, we can see in the waveform that we get these quantization artifacts, which makes it more choppy. So we have these discrete jumps which correlate to these harmonics here, which make it sound noisy and hissy. We get only odd harmonics no matter what. Lowering the bit reduction does emphasize the up harmonics more than the lower ones, and bit crushing the signal to oblivion, leaving only a few bits, emphasizes now the lower harmonics more. Using too few bits can result in having no signal for our sine test signal. With the minimal resolution and raising the drive, we get at -6 dB below clipping level our clipped signal. Using pink noise at this clipping range results in this gritty noise texture. Let's reset the values here and look at the downsampling. It also adds those discrete steps, but not on the amplitude, rather on the time axis. So raising this will introduce those overtone modes we see here, so we can control where those are via downsampling. We can combine these parameters now for a variety of sounds, knowing that except for the aliasing modes, only odd harmonics are introduced. Let's take this Apple loop here. Trivial case is to use it for top-end hiss, and that reminds me of electric static. We can make this loop more lo-fi, hyper-popish at the same time. Daft Punk uses Bitcrushing at the end of Short Circuit in case you want to check it out. Together with the test sound generator, we can do some simple sound design.